Hey everyone. So at this point we have a basic dice game, and the idea now is to expand it and make it a bit more interesting and learn a few things about programming at the same time. So in this video we're going to focus on working from the previous milestone, which is E1 P1 M3 die game basic. So what you can do is just git check out that tag, and then that will be a good place to start from. And so then the challenge then for this one is firstly find a drier way to determine dice game winners that is independent of the game classes. So take a functional approach. So let's have a look at that one in this video. So what we're going to look at is we'll go into dice, and this is my new implementation here. Now, one thing I'm going to show you is something called GitLens. So you can add the GitLens extension into VSCode, and what that allows you to do is just compare your code to an older or another commit. So we can have a look at open changes and then open changes with branch or tag. And then I'll go back to the die game basic before I made any changes to it. So here it is. And so I have the old one on the left. So what I want to look at is just to remind ourselves of how we were updating scores at the end of a round and then at the end of a game. So what we had to do was say use this lambda function to get the max score of any player for the round, and then we were to say, okay, well, which players are on that max score? And the reason we kind of need that extra little bit of complication is we can have multiple winners. So we can't just simply use the max and call it a day. We do the same thing at the end of the game. So we're basically repeating the code here. Now, the only real difference in the code is the attribute that we're going to test the max on. So we're doing it on round score, and then later on we're doing it on game score. Right, so we have this kind of repetitive code, which can become a bit of a nightmare to maintain, as the application gets bigger. You make a change and it turns out that it needs to be changed in three other places, slight differences. Yeah, it can become a bit of a mess. So now we could stay within our object-oriented world and we could actually get around this and create kind of a generic class. We could do something like, get attr, and we could pass in round score as a string into this update scores. And then for the next call, we simply pass in game score as a string. And we use get attr to kind of dynamically tell us which attribute we're going to use to determine the max. And that's actually fine. That will work fine. And the only issue with getting into using get attr and set attr is you're kind of monkeying with the class a bit more than you'd like to. Um, Classes are meant to be encapsulated and just expose methods and attributes kind of in a more kind of principled fashion. Um, and then I suppose to deal with that, you could just create some custom methods within the class that allow you to do this probably a bit better. You could also do something like a comparable. You could make the player objects comparable, um, and then have some options around the comparison. So there's kind of lots of different ways you could do it. But it strikes me that what are we really doing here? Well, we're just saying, well, if you give me a list of something and you give me a function that determines, some value on that something, and then let me rank those things, right? So like this kind of ranking is functionality. It's nothing to do really with the game. It's not specific to this game or to players or to cards or anything like that, or to dice games. It's basically something very generic that we could probably just program. Um, so a nice way to do this might just be as a what we call a pure function, which is really independent of our kind of class structure that we created. And that's what I've done here. So what I've done here is I've replaced all that with a function called find winners. And what I do is I simply pass in a lambda to it. And I pass in the players, and then the lambda for this one will be, well, for each player, return the round score. And then later on, I do the same thing. Where is it? Find winner. Do, do, do. Yeah, that should be game score actually. Yeah, see a bug. I'm gonna change that in the code. Um, so anyway, that's kind of the way it's working. So this should be game score. That's what we're gonna compare this time. Okay, and then that's our code. So it's a lot neater. It means that our code is a lot drier. We're simply passing off that comparison to a function. So let's have a look at that function. So I put it out in collection utils here. And the idea with these utils is they can be used across games, any game in the casino. We could even consider moving this maybe even to a shared area if other applications in our repo want to use it. But for now, it's fine in collection utils in casino. And we can see then the code here. So it's actually only 2 lines. It's something that's, once you think about this more generically, we kind of realize, well, all you're really doing is you're providing, some kind of list of items, you're providing some function that allows us to compare the items, and then we're doing the comparison. So what do we do here? So we take in items as a sequence, and we take in the key, and we simply kind of work away there. We return the list of winners. So we're getting the max key items. We run the function on the item, and then we get the max of that for all the items. And then we say, okay, for all the items, if their um, result of that key item is the max, well, then they go into the winner list. So, like, it's very, very generic. Um, and we can test that out then, just like we'll do an informal test within the module here for the moment, before we get to PyTest and all that. So we're just saying, okay, let's just have a simple list here. And we can see that these ones should be the winners. We're going by the max. So we're going to go and call find winners with the items. And the lambda here is just very straightforward. We're just saying for every x, just return x. So the lambda is not doing too much work here. That's fine. And then the winners should be these fives here. And then, yeah, we just check that out with the assertion. Um, and then we can do an example that's a bit more like our player and their round and game scores. So we create a little test class called test, and we have a method get value, and we simply instantiate that class with these different numbers that sets the value, and then we go off and find winners. This time the lambda is doing a bit more work, so it's going to call get value to get the value for each of those items, and then it's going to find that list of winners. So we can then go and test that, and we can test that we're going to get these last 6 items back. Just notice I'm using set here because we don't actually care about the order in which they're returned. So a set will just basically say, well, look, it's the collection of items, of unique items returned, irrespective of order. We don't care about order. So that's why we're converting to set here in the assertion. So we can just go and run that then, and we can see that that passes. We've no fails here. What's that? Come on, just make sure that's working. Run without debugging. Yeah, that's working fine. Okay, so that's the idea here. So we're kind of like, even though we might want to stay in kind of the OOP world for organizing our application as a whole, there's often places where functional programming can be very useful. And it's particularly useful when we want to do something that's really kind of something independent or, of the object-oriented structures that we've created. And in this case, that's one of them. All right. So that's a bit of functional programming. And then the last thing I just want to draw your attention to here in this solution is this idea of typing. So some people kind of in Python are saying, well, typing, do we need it to be typed? It's a dynamically typed language. Isn't the whole thing about Python that we can really just specify them at runtime? And I think that's true to a point. But for functions like this, it's very useful because what we're doing here is we're saying, well, look, here's a function that it really just operates independently of all those objects and kind of domain knowledge that we've kind of put into our application. But we do want to make it clear to the users of this function, what's required, what are the allowable arguments you can pass into it. So it's actually pretty useful to say that, well, items is actually going to be a sequence, and a sequence is simply a list or a tuple or something like that. of items T, and then to say that, well, the key is going to be a callable on T, so it's going to be a method or a function or an attribute, and then it's going to return a float, right? So and then that the actual find winners function itself is going to return a list of those objects that you passed in the first place. So in this first example, it's just a list of primitives because that's all we passed in. And then in our second example, it's gonna return a list of these test objects. So I think in this case that the typing is actually pretty useful because these classes can look pretty abstract and you're kind of wondering, well, what are the allowable kind of circumstances where I'm going to use this thing and how am I going to structure my call and what do I expect to get back? Um, you know, and you don't really have too many clues because it's purely functional. It's not referencing any of the domain classes that we created. So your mileage will vary in type hints, but I think for kind of this functional programming that they're certainly very very useful and worth putting in. So that's it. So we've covered finding a drier way to determine the dice game winners that's independent of the game classes, and we've done a bit of type hinting for free. So that's kind of the first part. So we'll do the next ones in other videos then. Okay, have fun with your own implementation.